And what I really hope what comes out of the Game Jam is not only some great games that people are working on and are excited about, but some libraries that are even easier to use than Pygame. And some things that are so clearly hackable that when people start to play with them, they realize when they're done they've made something new. And I think that you'd be amazed at how quickly that attracts those little pieces that kids can obviously change and see they've done something and show to their friend, how quickly that draws the attention away from whatever else is available.
Hi, I'm Darius Kazemi. I work at Orbis Gameworks in Austin, but I also help organize the Boston Game Jam earlier this year. I've also been part of the Indie Game Jam, which some of you probably heard of. I just wanted to give you a few hints as to how to make sure that you actually get something to show out of this jam, because it's a very short amount of time to work on your game. Number one, front load your risk. So if you want to make a game about that depends heavily on, say, the mesh networking, make sure you can get that working first, and then build all the other stuff around. So find your most risky component and sort of
the man behind the curtains.
and get that done first. Second, get something playable as soon as possible. My cynical take on this is that if you don't have something playable by probably midday or late Saturday, you're kind of in hot water. So get something playable soon, right? That way, as long as you have something playable, if the jam ends like tomorrow for some reason, you got something done, no matter how late it may be. Also, if you are depending on art assets, take advantage of the artists sooner rather than later. Let the artists who are here to help, and I know Rob is one of them. I don't know if there are any others here. Raise your hands. Talk to the artists early, because if everybody walks up to Rob on Sunday morning and says, "I need all these assets," he's not going to be able to get that for people. So think ahead. That's sort of what all this stuff comes down to. Think ahead and have a playable build.
The documentation is at pygame.org/docs, and it's actually pretty decent. There are some places where we differ from the docs, and that's basically all I'm talking about and giving a rough overview to how Pygame works. Okay, so the basics. Pygame is a cross-platform game development library. This is important. We do not have enough exos for everybody to be continually testing on the exos. But because we're going for 100% API emulation, you can test it on your laptop, and that'll be pretty much the same thing as testing on the exo. So you only need to test on the exo every now and then. It's based on SPL, but don't quote me on that because we might be changing some things under the covers. Don't peek under the covers if you don't have to, or talk to me beforehand, please, so that we know what you're trying to do. Basically, all Pygame does is what SPL does. It handles input, so you can get keyboard and mouse events, and joysticks, but we don't have any of those really. And it handles output, so it allows you to draw graphics to the screen, it allows you to play audio. The basics of Pygame. Import Pygame. Can we turn off the front row lights or something so we can see this better? I can't like just lower the first row. No. Inconvenient. Thanks for trying. Good program. Okay, so you import Pygame, and before you do anything else with the Pygame library, you must call pygame.init. This initializes all the data structures behind the scenes. You only have to do that once. If you do it more than once, it doesn't matter. And cue music. Okay. Okay. So the way you get a screen, Pygame.display.setMode, you pass it a resolution. This gives you back an object called a surface. The surface is magical. It is linked to the screen. Specifically in the context of Sugar, it will be linked to a portion of the screen, but on your computer, it will be linked to a whole window. So the way you draw is you draw things onto the surface. I'll get to that in a little bit. If you ever need to get if you need the screen object and you, for some reason, don't have it in a certain function, you can also call Pygame.display.surface. Pygame.display.flip is how you flip the screen buffers. Everybody know what that means? Yes? No? Good? And Pygame.display.update is how you flip only portions of the screen, aka dirty rect updating. This is good. Surfaces, the basic element of graphics. This is a pretty common model, I think, for most games. Yes, except maybe Flash, because Flash is crazy. Load files, this returns a surface object. One thing to be aware of is alpha transparency. So there's these two functions. One is .convertAlpha. This returns a new version of a surface with per pixel alphas set up if it's on a file format that supports it, like GIF or PNG. So you can do that, or you can use color keys. Now, normally people will say color keys are faster, but the EXO has hardware accelerated alpha flitting in the Geo processor. Now, this isn't actually hooked up to the hardware paths yet, but it eventually will be. So right now, alpha flitting may be slower, but in the end, it is probably going to be faster than color keys. I'm not quite sure how the best way to handle this is. You'll have to see how your game works. Hopefully, it won't be an issue for anybody. The way you draw a surface onto another is blitting. Destination surface, dot blit, the source, and then the XY coordinates that you want to blit at. That's the XY coordinates in the top left corner. Everybody with me? Feel free to stop me at any time if I'm going too fast. I tend to talk quickly. These are the formats supported by Pygame. As you can see, there's lots of them. Probably the only ones you should care about are JPEG and PNG. GIF is probably not a great idea for various licensing reasons that will make people in the office cry. One thing that you will see is not in that list is SVG. This will have to be worked out at some point, but we haven't gotten that far yet. So right now, just use PNGs or JPEGs and don't ask any questions, please. Or do ask questions and help decode it. So yeah, stay tuned on SVG support. The basic game loop in a Pygame game. Pygame does not provide a main loop like GTK or QT or many other large-scale graphics toolkits. So you have to write your own main loop. This is the rough shell of one. I'm going to go through this step by step. So the first part, timing. Pygame has an object called clock from pygame.time import clock. It's a very simple way of both keeping a steady frame rate and giving time deltas or time decoupling. Time decoupling is good. So you make a clock object before you start the main loop, and then each frame you can call clock.tick and pass it a frame rate, and it will return you the number of milliseconds since the last frame. Pretty simple, pretty easy. I put 30, that's probably a bit much for an EXO game, just because obviously computational resources are expensive, but you can play with that on your own. One thing of note, in the Bitfrost specification, which is our security document, there's a limitation on the amount of processing power you can consume when you are backgrounded. So we will have to at some point provide support for informing games that they have been backgrounded and they should reduce their frame rate probably to like 1 frame a second or something. But that's not done yet. So just keep in mind that you may have to support variable frame rates in order to reduce your computational resources. Or alternatively, we can set up something so it pauses the game and the frame rate obviously drops to 0 when it backgrounds. Keep that in mind while you're designing your game, but know that it's not done yet. Event handling. So, okay, this code looks like crap because I wrote this in Keynote, and when I exported it to PowerPoint, all the monospace disappeared, but whatever. So basically, Pygame is not callback driven, it is entirely polling driven. So you ask it in each frame for all the events that have accumulated since the last frame, and you iterate over them. This returns, essentially, this iterates over all the events that have occurred. There is an event object you can look up in the documentation, the specifics. I'm going to go over some basics of the event handling, but there's a lot more events than I'll talk about. The one that you should always, for one, you always have to be checking event handling because that's where it does all the operating system interface stuff. So if you don't at least call this once per frame, you'll let events crash, and it'll seem like your program is frozen. And you should always check for the quit event type, and if it sends a quit event, quit. That generally means that in Windows you click the red button in the top right corner, or whatever else the operating system does to close programs. Other common types of events. I'll go through these very quickly. Key up and key down, obvious. Mouse motion, that just means mouse is moved, mouse button up, mouse button down. Clear? Yes? Good. Nobody's saying anything, so I'm hoping everybody's with me. So basic key events, there is another member on key events called .key, and there are key code constants in the Pygame module. You can compare them. Gee whiz. See the Pygame documentation for a full list of key constants. They're pretty easy. Special keys are all uppercase words like K_escape, all uppercase, and letters are the letter lowercase. Mouse events, there is a .pause member on all mouse events. That's motion and button presses. So you can tell where the press or movement occurred. And on the button press events, there is event.button. This is 1 for the left mouse button and 3 for the right mouse button. No 2 because we don't have a middle mouse. Was that your question?
So the position is just the absolute.
Yes, it is the absolute. There is a delta. There's also a .rel, which is the delta movement, which you can use too. I generally don't find that as useful, but I suppose it isn't good in some cases. Okay, update phase. So this is as good a place as any to talk about sprites. Pygame does support sprites, but they are incredibly simplistic. A sprite is just a surface and a position combined in one object. But there's some nifty extra support for them if you use sprites. You obviously don't have to because it's pretty level and free. Sprites live in the Pygame.sprite module. It is a class. Generally, the way you will use sprite is you will inherit from it in your own subclasses for your game objects. That's how you subclass in Python, in case you forgot. You must call the superclass init because there is some data that's set up internally in the sprite class. The two important attributes on a sprite: it must declare a .image, which is whatever should be drawn, and the .rect. These can be properties if you know what they are, but if you don't do it. But these can't be functions, they must be attributes, and they must exist for the other sprite support functions to work. So one of the nifty things that you can do if you are using sprites is use groups. Some are fast ways to deal with collections of sprites. Their basic one is just group. That one doesn't really do much other than it's a collection of sprites. But I'll get to the shinier ones, render updates and order updates, in a minute. So .add and .remove, you can either call group.add_sprite or sprite.add_group. It doesn't matter, it does the same thing. Since I was talking about updating, one nifty thing is each sprite class has an update function. The group also has an update function that will just call update with all the arguments that it was passed on all of its sprites. It's just a minor piece of syntactic sugar. It's helpful. So the draw phase. So this is where those two rendered updates and ordered updates come in handy. So on any group you can call .draw and pass the destination surface, like the screen, and it will draw all of its sprites to the screen. Now the standard group doesn't really know how to do very much. It draws them in a random order and doesn't really do anything useful. However, the other ones, rendered updates and ordered updates, so rendered updates does dirty rects tracking automatically for you. So the .draw function will return a list of changed rects. This is handy if you don't want to have to update the whole screen every time. You don't want to track that yourself because it's annoying. And so you can do .draw on a rendered update or ordered update, and then just pass the accumulated. So if you have multiple groups, you accumulate all the dirty rects and pass that to Pygame.draw.update. Very handy. If you're doing layering, ordered updates is even more handy because ordered updates it keeps track of the order sprites were added to it and make sure to draw them correctly in that order, so you get Z layering, which is nice. This is also a good time to talk about rects because it doesn't really fit in anywhere else. We're done with the main loop, so now we're on to other miscellaneous topics. So a rect is just a rectangle in Pygame, but they're kind of used everywhere. They're used for both size information and location information, and both, depending on the context. So an easy way to, if you have an image and you want to get its size as a rect, is to call surf.getRect. This will return a rectangle of the correct size, which starts at 0, 0, but you can then move it. This is very commonly done in sprites. If you want to have the rectangle correlating to the image you just loaded, then you want to start moving it. I'm not going to go over all of the functions or attributes of rects because there's a lot of them and they're very useful. Look them over in the documentation. These are the attributes it has. These are all readable and writable, so you can move it around by calling any of these, or there's a bunch of functions to move it around and resize it, both in place and non-in-place versions, depending on your needs. And rects are very fast because they're antsy. So collisions, there's very basic collision support, again, using rects, so it is only rectangular collision. If you need things like one of those circles, well, you gotta roll your own, sorry. So there's sprite collide, which just checks if it returns the list of all sprites in the group that the given sprite collides with. There is sprite collide any, which just returns if the given sprite collides with any in the group, which is, needless to say, slightly faster, because it has to do less. And there is group collide, which is for every sprite in group 1, run sprite collide on group 2. The kill arguments to sprite collide and group collide just remove any colliding sprites from their groups. It's a little bit faster than doing it on your own, but not by terribly much. Sound, we'll go over this quickly because it's pretty simple. There is a Pygame.mixer.sound object. It loads both WAV files and OGG files. For space reasons, you should obviously probably be using OGGs. I think it does support MP3, but there's, again, licensing concerns. So you should probably use OGG unless you get a really good reason not to. If you need help transcoding from MP3 to OGG, just ask around. I'm sure there's people who know how to do it. So the sound objects have a .play and a .stop. Pretty simple. That's all there is. Pygame handles all the mixing and the background spreads. You don't have to worry too much about that. There is one specific sound object, which is a singleton, that is good to know about, which is Pygame.mixer.music. This is different than all other sound objects in that it understands the stream from a file, so it doesn't have to load the entire sound into memory. This is good for things like long background music. Unfortunately, because it's a singleton, you can only do this once. You can only have one music channel playing. I don't know why they did that way, but they did. Text, don't do it right now. The problem with text is that we have to support an obscene number of languages, including languages with really painful rendering methods like Arabic. Pygame, by default, uses SDLTTF, which has absolutely no knowledge of any of this. So we have to hook Pygame into Pango somehow. Pango is the GTK text rendering library, but we haven't figured out the best way to do that yet. So please try to not use text for a variety of reasons. Also in your games, kids probably won't know how to read, or it's very likely that they won't know how to read if they're young, so yes.
Text as a font, but text as a graphic is fine, right?
No, because text as a graphic is the worst. You can't internationalize that at all. Again, you have to, unless you want to customize the graphic for every language, which consumes a huge amount of space. Basically, try to avoid text at all costs. Use iconographic representations whenever possible. You absolutely have to use text. Talk to me. Try to make it a placeholder and try to make the design in the game flexible. Yes?
So what would you do for instructions? Because I seem like the games used to...
You probably want some kind of guided tutorial that steps through one step at a time using, white colorful arrows as to what to click. Any question? Okay. Yeah. Text is a problem on a lot of levels. Like I said, can't assume that kids can read, and we have to support a huge number of languages, so any you have will have to be internationalized, and that's a lot of resources to track down people who do that. Yes?
Numbers,
Yes, numbers are pretty safe.
So what would you do for instructions? Because I seem like the games used to...
You probably want some kind of guided tutorial that steps through, one step at a time, using, white colorful arrows as to what to click. Stretching or asking a question? Okay. Yeah. Text is a problem on a lot of levels. Like I said, you can't assume that kids can read, and we have to support a huge number of languages, so any text you have will have to be internationalized, and that's a lot of resources to track down people who do that. Yes?
How about numbers? Consider that...
Yes, numbers are pretty safe. Mostly because basically, I think everyone will be able to read Arabic numerals. But again, kids may not know how to read, so try to avoid them. Use iconographics, use actual counts of things if possible. It's just more likely, unless if the idea is to teach them numbers, fine, that's a different issue. But if you can avoid it, try to.
So it's implemented on the Exo, like it'll render text. What you're saying?
It'll render text, but only basically it'll render Latin one. It will not render things like Chinese or Arabic, because Arabic rendering is incredibly complicated. I think that's basically it I have. Yeah, that's the documentation. That's my email address, Noah@laptop. It's pretty easy to remember. If you have any questions, feel free to find me, email me, something. People here have my cell phone number. If something really explodes. I will be handing out either via email or IRC more information on the SDL GTK bridge that I've been working on that lets you use Pygame within Sugar, which is the graphical system on the Exo. So I have that in a Subversion repository. If you don't have Subversion, you should probably go download it because all my code is in Subversion. Yeah, I think that's about it. I have questions.
Well, I wanted to... Actually, let me see if there's any other questions on your talk, and then there's some other issues that we should bring up.
Yeah, if I can also talk about in relation to project management, and was that what you were going to talk about?
That was what I was going to ask.
Okay.
Okay, can I maybe I'll ask you after this.
Okay, so, no longer talking about this, but anybody who wants it, I will offer free Subversion and Track hosting. Track is a wiki and a ticket tracker and a source browser that's web-based. If you want, a wiki or a bug system, and I can offer free Subversion hosting for anybody who needs it, just because multi-use development without some kind of version control system makes me very sad. I don't know if people do it. If anybody's interested in that, just talk to me. Basically, I just need a list of usernames and passwords. I'll probably just give everyone the same password because I don't really care that much. Yeah, or I can have people register. But not me. I'll something.
So the recommendation is, yeah, do that, please. Post your games. The whole point of this is we're trying to share this stuff and make it publicly available. And so talk to Noah, get a Subversion account, check your games in, And
If you've got your own system, that's fine. Just please make things public as they're happening. The idea is for this to be as transparent as possible.
yes, and so a couple other things. We have a wiki, and there are some instructions over there on it. Please account, put a page up about your game, and links to anything that you have. If you're not using his version repository, put one of your own or whatever. And IRC is running right now. We have a Game Jam chat channel. If anybody's ever done anything like, a Game Jam or any of the, what are the other things I'm thinking of? Bar camp, food camp, that kind of stuff. Generally, they have a back channel running on IRC. It's really nice to be able to say, hey, does anybody know how to X on there, rather than going around and tapping everybody on the shoulder. So, there are, probably MIRC if you're using a PC, Colobi if you're using a Mac, XChat, whatever it is, a bunch of them. So find an IRC chat and get on the channel and just kind of keep an eye on it as the game jam goes on for the weekend. There's a bunch of stuff going by there. One other thing about it. I'll say it later.
So a couple more administrative notes. The other thing is, I'm curious what the breakdown of languages is for the people who already have an idea of what you're going to program in. So I just wanted to put up on the board and go around team by team. If you can write things in Python using raw GTK to do your display rather than using Pygame.
GTK is a desktop application toolkit. It's for making your average desktop app. It's not very well designed for games, unfortunately. I found it generally slow for games. The main loop is optimized for user-driven content, not system-driven content. It does, it's for doing things like the menus and the edit fields and all that. The low-level Sugar system, Sugar is the graphical environment on the XO, is written using GTK. And that's where the initial support is being added for things like the microphone, the camera, networking, internationalization support, all that. So all of that is pretty much already either implemented or will be implemented soon in GTK. And we're bolting Pygame and Python on top of that with a bizarre, unholy grid that probably shouldn't exist.